In this video, we're going to learn how to verify a number is prime. So first, some definitions. What is a prime number? So a prime number is a whole number greater than 1, so we're only considering numbers 2 or greater, okay, whose factor pairs are only the number itself and 1. Okay. Now we have a composite number. Basically, a composite number is a number that's not prime, which means it has at least one factor other than itself and 1. Okay. So here are some of the smallest prime numbers. Okay, so all of these are prime, and if you were to try to make their factor pairs, the only way to write 2 is 1 times 2. The only way to factor 3 into 2 factors is 1 times 3. 5 is 1 times 5. And this is true for all of these numbers. Okay, so this is our smallest list of prime numbers. Now, here's a nice fact, and we're going to justify this fact when we do the first problem. To determine if a number is prime or composite, we only need to check to see if the number is divisible by the prime factors whose square is less than the number we are trying to factor. Now, I know that's a mouthful, but it's very similar to the idea of finding all of the factor pairs. Okay, but instead of looking at every number, we're only going to need to look at prime numbers to verify a prime number. Okay, so we're going to look at the first example and see why this is the case. Okay, so here's our table of prime perfect squares. So notice we have 2, 3, 5, 7, 11, 13, 17, 19. We didn't include 4, 6, 8, 9, 10 because none of them are prime. They have factors besides 1 in themselves. Okay, so here are the directions. Verify that the following numbers are prime by checking to see if the number is divisible by any prime numbers whose square is less than the number given. So first, let's find the largest prime that we have to check. So our number is 89, and looking in this chart, 89 is between 49 and 121, and we have to look at the smaller one. So 7 is the largest prime number we have to check to see, to verify if this is prime, meaning specifically we only have to check the factors 2, 3, 5, and 7. And if 89 is not divisible by any of these numbers, then we have verified or proven that 89 is prime. Okay. Now let's just start thinking of this as writing factor pairs for 89. Okay, so we know 89 can be written as 1 times 89. Okay, this is true for all numbers, and remember the definition of prime said that a number can only be written in this way with whole numbers. Okay, so now we could check 2. So I'm going to get the calculator out. Now 2 is not even, so a number is only divisible by 2 if it ends in 0, 2, 4, 6, 8. But we will divide anyway, and I see that there is a remainder. Remember, that's a decimal, that the remainder isn't 5. Okay, the remainder is actually 1. But now I know it's not divisible by 2, so I can cross that out. I need to check 3. So I'm going to divide 89 by 3, and if I get a whole number, it's divisible by 3. But notice I do not. So 89 is not divisible by 3. Now, normally with our factor pairs, we would check 4. Remember I said we only need to check the primes. So let's see why we don't have to check 4. I'm just going to write this over here. So say I wanted to see if 89 was 4 times a number. Well, 4 is 2 times 2. Now I know this would be some new number. I know that 89 is not 2 times a number, so it can't be 2 times 2 times a number, okay? Meaning it cannot be 4 times a number, okay? So checking 4, once we know it's not divisible by 2, it cannot be divisible by 4, so we don't even need to check it, okay? So we can move on to 5, okay? 5 is another one that's nice and easy to check. A number is only divisible by 5 if it ends in 0 or 5. 89 does not, but just to verify it, divide see if we have a remainder, and we do. So it's not divisible by 5. Okay. Normally we would check 6 next, but again, if it was divisible by 6, 6 is 2 times 3, then it would have been 2 times a number or 3 times a number, which we know it's not. So we don't even need to check 6. Finally, we check 7. If we divide 89 by 7, we see that there's a remainder because there's a decimal there, so it is not divisible by 7. Okay, so you can't just look at 89 and say, that looks like a prime number, I can't think of any factors. To officially verify and prove that 89 is prime, you need to check to see that it's not divisible by any of these numbers. Since it is not, we can now therefore conclude it is prime. We have verified it. Okay, let's do this for 163. So 163, looking at these numbers, it falls between 121 and 169. Remember, you go to the smaller number. So that means we only have to check primes up to 11. And that means we only have to check 2, 3, 5, 7, and 11. So we're only checking 4 numbers, or 5 numbers, which really isn't a lot of work. Okay, so let's see. Is it divisible by 2? So we know we have 1 times 163. All numbers do. Well, it's not even. Okay, you can verify that by dividing on your calculator, but it ends in a 3, so it's not divisible by 2. Let's see if it's divisible by 3. Check on the calculator. 163 divided by 3. No, it's not. There's a remainder, so we'll cross out 3. Next, we can check 5. Notice it doesn't end in 0 or 5, so it's not divisible by 5. If you want, you can check on your calculator, but I'm going to cross that out. Now we'll check 7. 163 divided by 7. Notice there's a decimal, so that means there's a remainder. So not divisible by 7. And finally, let's check 11. And there's a remainder, so it's not divisible by 11. So we have verified that it is prime.